Today we'll be looking at our last mini unit, which is looking at trigonometry. Now you've done some trigonometry before. If you think about Pythagoras' theorem, that's trigonometry. So Pythagoras' theorem, a squared plus b squared equals c squared. That equation relates the lengths of a triangle to each other. Right, and remember that Pythagoras' theorem works in any right angle triangle, anytime you have a 90 degrees. Right? A is one side length, B is the other, C is the hypotenuse, the longest side. A squared plus B squared equals C squared. So that relationship is involving the angles. Today what we're looking at is some other relationships in only right angle triangles. So other relationships in right angle triangles, but this time involving the angle as well. And these are called the trigonometric ratios. Normally I have you guys go through and do an investigation and come up with those equations yourself, but it takes quite a while, so we're gonna skip that for this year. But you can come up with these equations by just going through and measuring a bunch of different triangles. So you measure the lengths, you measure the angles, you start to compare them together, and if you do enough of them, you start to notice these patterns. And what those patterns show you is that whatever angle you're looking at, that angle has a ratio between the side lengths. So for example, let's say I was looking at this triangle, and it was, we'll say this angle was 40 degrees. And I go and I measure my lengths here. And I look at the ratio, the fraction between those two lengths. And then I go and I look at a different right angle triangle, a bigger one, that's also 40 degrees, and I look at the ratio between its side lengths. And then I go and I look at a tiny triangle that also has a 40 degrees angle, and I compare its side lengths. And what we start to notice is that those ratios match up because it's the same angle in there. So regardless of the size of the triangle, the angle gives you the ratio between the side lengths, the fraction between the side lengths. And if you do this with a bunch of triangles, you can come up with a table. So for example, here's a trigonometry or trigonometric table for different angles. So you would go and you would look up 40 degrees. And here's my angle, 40 degrees, and it would give you the ratio. So if you took the two side lengths and divided them, you'd get 0.64. So that's the ratio when your angle is 40 degrees. And you could do this for any angle, and they've done it all the way up to 90 degrees. Now, they've actually built these tables into your calculator. So you see that sine, cos, and tan. Depending on which sides you're interested in, you'll use one of those three. And these tables, if you go look at your calculator right now, I'll pull up a calculator, those tables are actually built into your calculator already in the sine, cos, and tan buttons. So when you press these buttons, all it's doing is your calculator is going to some table, and it's just looking up what is the ratio that matches up with that angle. So that's all these fancy sine, cos, and tan buttons do on your calculator. All right, so before we can do any of these problems, there is one kind of rule for labeling the triangles. So we do know already from Pythagoras' theorem, we know that the longest side, the one that's opposite from your 90 degrees, the longest one is the hypotenuse. There's always some angle that you're interested in when you're solving these. So either you know that angle or you're trying to find it. And what we can do is if we look across from that angle, so you take that angle that you're interested in or that you know and you draw across from it, we call that one the opposite side. And then the leftover one is called the adjacent side. So you need to start these problems by always labeling your triangle. And that's how you do it. So we'll do one more here. The longest one, across from the 90, the longest is the hypotenuse. This is the angle that we're interested in, or we have. So we're going to go across from it. We call that the opposite. And the leftover one is the adjacent. So you always start by going through and labeling those. Now, there's only ever two sides that we're interested in. And depending on which two you have or you want to find, that will tell you whether you should use the sine, the cos, or the tan. So there's three separate equations that we have, one for sine, cos, and tan. And that matches up with kind of the 3 buttons on your calculator, the 3 different tables that it would look in. Okay, so the first one, sine. And you'll notice we have kind of these acronyms, SO, CA, TOA. Those are just used to help you remember the 3 different equations. So SO, it gives you the equation for sine. So SO stands for sine theta. Theta is an angle, so sine of an angle equals opposite over hypotenuse. So when you're solving an equation, if opposite and hypotenuse, if those are the important sides, so sides that you either know or you want to find, then you would use the sine equation. Sine theta is opposite over hypotenuse. Okay, the next one is ca, which means cos theta equals adjacent over hypotenuse. So once again, that's just to help you remember the formula. Cos theta is adjacent over hypotenuse. So when you're solving a problem, if adjacent and hypotenuse are the important sides, then you'd use this equation. And the last one, TOA, stands for tan theta equals opposite over adjacent. And once again, if opposite and adjacent are the important ones in that equation, or in that problem, then you'd use this equation here. So really, these 3 equations here, knowing how to use those and which ones to use, that's really the biggest thing in this unit. And you'll need that next year for sure. So we're going to do a little bit more practice labeling the triangles, and then we'll do some examples. All right. First one. So here it just says state the primary trigonometric ratio. So that just means SOHCAHTOA for the following triangle. Okay. So in this case, I'm not actually given anything to solve. There's no x's or thetas anywhere. The theta is just, it's like an x for an angle. So if you see a theta, it just means some unknown angle. In this case, I know everything. I'm just practicing writing down the equations right now. So first thing we do, label the triangle. All right, the longest side is hypotenuse. This is the angle I'm given, so across from it would be opposite, and leftover side would be adjacent. All right, so let's practice writing our 3 ratios down. First one, sine, or so. So means sine theta is opposite over hypotenuse. So I'm just going to pull the info out of here. Sine of my angle, so sine 30, equals the opposite, which is 1, over the hypotenuse, which is 2. There we go. So that was your sine equation from this triangle. Now let's quickly use a calculator and see if it makes sense here. One thing you need to check whenever you're doing trigonometric ratios, make sure that your calculator is in degree mode. So there's probably somewhere kind of in the top, you might need to press like a second button in order to change the mode, but make sure that it's in degree mode. Usually the calculator in the top right, it might say like RAD. That means it's in radian mode. That's the wrong mode. You want to change it so that it says DEG, or sometimes it just says nothing if it's in degree. You can actually test, when we plug this in, you'll see if you're in the right mode. So in this case, I was looking at sine of 30. So in this case, if I plug in sine of 30, we end up with 0.5. So just make sure, plug that into your calculator right now. Make sure that you get back 0.5, because that'll tell you that you're in the right mode. If you get back something else, make sure you somehow switch that mode into the degree mode. Now, if we double check, sine of 30 is 0.5, and 1/2 is also 0.5. So yeah, that equation makes sense. It seems to be valid. Whatever we're doing here is working. All right, let's set up our next equation. Next equation, we'll use ca, so cos equation. Cos theta is adjacent over hypotenuse. So plugging in everything from this triangle, cos of theta is cos of 30. That's the angle we're looking at. equals adjacent, which is 1.7, divided by the hypotenuse, which is 2. Okay, so there's our next equation. Once again, there's no unknowns here because we actually know everything about this triangle already. We're just practicing setting up the equations. Let's plug this guy into our calculator and see if it makes sense. So cos of 30 is 0.87. And the other part was 1.7 divided by 2. Okay, there's a little bit of a rounding error just because I had to round off the 1.7, but they're essentially the same number. So what did the cos of 30 do? Well, when I plugged in 30 degrees into my cos, all my calculator did is it went to that table and it looked up what is the ratio between the adjacent and the hypotenuse lengths. And it told me, oh, in that shape of triangle, the ratio is 0.86. And then sure enough, when I looked at my lengths, my adjacent and hypotenuse lengths, that was the ratio that I had. And last one, we'll use tan now, TOA. So TOA, tan is equal to opposite over adjacent. So tan of theta is tan 30. You always have to put something into the sine, cos, and tan. You never have sine, cos, and tan on their own. There's always an angle that's going into it, right? Because you need some angle to look up on that table. So tan theta equals opposite. My opposite is a 1. Divided by adjacent, which is 1.7. There we go. We'll double check if that equation makes sense or if it works. Tan of 30, 0.58. 1 over 1.7, 0.59, but in this case, it's just a rounding error once again. Essentially the same number. Right? In this case, that tan 30 really just told me the ratio of the opposite and adjacent lengths when your angle is 30 degrees is this, 0.58. And yeah, my numbers seem to match up. Right. These ones we can just kind of quickly practice plugging in a few more. So sine of 35, plug that into your calculator. Should get 0.57. Tan of 85, plug that into your calculator. Should come out to 11.4. So just do those really quickly just to make sure that you are using the calculator correctly and that you're in the right mode. All right. Let's go on and do some full examples now. 2 examples here. First one. In this case, you're given a right angle triangle. Remember, SOHCAHTOA equations only work for right angle triangles. All right, so it looks like we know this length is 10. We know the angle is 65 degrees, and we want to find that length over there. All right, step number 1, label your triangle. All right, my longest is the hypotenuse. And you know what? I actually don't care about the hypotenuse here. I don't have it. I don't know the length. And I don't need to find it. It wasn't asked. So I'm just going to leave that one out. I don't care about the hypotenuse. This angle is the one I'm given. So it will look at the opposite side. And the leftover side will be the adjacent. All right. So now I'm going to look through and I'm going to say, okay, right, SOHCAHTOA. And I say, okay, opposite and adjacent are the important ones in this problem. So which equation am I going to use? Opposite hypotenuse, adjacent hypotenuse, opposite adjacent. Oh, okay, I'm going to use TOA. I'm going to use my tan equation. So that's why we use this thing to figure out which equation, right? Opposite and adjacent. I'm looking at the last 2 letters. The only ones that have opposite and adjacent is tan. So I'm going to use my tan equation. Tan theta equals opposite over adjacent. So I normally write this at the top of my page, and then I can go through and say, okay, which one has the two sides I'm interested in? And that'll tell you which equation to use. Okay, so I write my equation down. Tan theta equals opposite over adjacent. And now I just fill everything in. All right, tan of theta turns into a tan 65. That's the angle. Opposite is an x, and adjacent is a 10. All right, now I have an equation I can work with. The x is the only unknown here, so I really just need to solve this equation for x, get x by itself. All right, so if you're solving that equation for x, what do you need to move to get the x by itself? You have to move that 10, right? Right now the 10 is dividing, so I would multiply by 10 on both sides. And that'll cancel out your 10 here. All right, that leaves me with 10 times tan 65 equals x. And at this point, those are all just numbers, all right? Tan 65 is just some decimal number, right, that comes out of that big table. So we can just plug this into our calculator now. 10 times tan 65, or if you had one of these tables, you could just look up what tan 65 is. Right, so we do 10 times tan 65. All right, and that gives me 21.4. Okay, so that side length there is 21.4. And at this point, we're done. All right, let's do one more here. Here, I'll move my SOHCAHTOA down because I'll need that. All right. Here's my triangle. Once again, I know one of the angles, I know one of the lengths, and I want to find that length over there. All right, start by labeling our triangle. Let's see, longest side, which is across from the 90, is the hypotenuse. My angle looks at the opposite, and I don't care about the opposite here. I don't have it, and I don't need to find it, so I ignore that. The leftover side is the adjacent. Okay, so the important sides here are adjacent and hypotenuse. So let's see, which of our equations are we going to use? Looking at the last two letters, adjacent and hypotenuse is cos, right? Cos. So I'll use the cos equation. So that one is the only one that has adjacent and hypotenuse in it. All right, so I write that equation down. Cos of theta equals adjacent over hypotenuse. All right, so I know which equation to work with. So at this point, I just plug everything in. Cos of theta becomes cos 58. Adjacent becomes 2.3. And hypotenuse becomes x. All right. So at this point, once again, I have an equation. I just need to solve it. Okay, it gets a little bit tricky when the x is in the bottom of the fraction. I think we've seen ones like these back in the first unit. We had to solve some equations like this where x was in the bottom. And the trick here is you need to first of all get the x out of the denominator, out of the bottom of the fraction, because you can't solve for it yet, right? Even if you move the 2.3, you still have 1 over x, right? You got to get it out of the denominator. And you can do that by just moving it to the opposite side. Right now the x is dividing, so I will move it by doing the opposite, which is a multiplication. So multiply x on both sides. That will cancel out here. And that leaves me with, oops, sorry. That leaves me with x times cos 58 equals 2 by 3. My x is canceled. So you'll notice by moving this, by doing the opposite operation here, that cancels out, and now my x is in the numerator. It's not in, it's in the top of the fraction, right? Which is where I want it. Okay, so now we have an equation that's a bit easier to solve. Now I can look at getting x by itself. The only thing I need to move is cos 58. That's just a number, so you can treat it just like any other decimal number. If I wanted to move that, right now it's multiplying with the x, so I would divide by cos 58 on both sides. Cos 58 cancels out. And I'm left with x equals 2.3 over cos 58. So whenever you get in that situation where x is in the denominator, just start by moving the x over, by multiplying, and then that will get it out of the denominator, and then you can just solve for it like normal. All right, plug this guy into my calculator. 2.3 divide by cos 58. 2.3 divide by cos 58 gives me 4.3. And we get x equals 4.3. You can do a kind of a quick sanity check here to see if the answer makes sense. Hypotenuse has to be the longest side in a right angle triangle. So you know your answer has to be bigger than 2.3, right? Yeah, it is. So it seems like a fairly reasonable answer. All right, so at this point, there's a couple of practice questions for you guys to try out. Really, the main thing here is label your triangle, figure out which two sides are important, match those two sides up with SOHCAHTOA to figure out which equation you use, plug in everything, right, and then solve it.